Good afternoon, student. This is the lecture number 39 of Unit 6, that is powder metallurgy. In the previous lecture, we have studied the production of the powdered component, the steps involved in the production of the powdered component. That is the production of powder, then mixing and blending, then sintering, compacting, sizing and impregnation, testing and inspection, the various steps in the production of the powder, and the different step followed by the production of the powdered component, that we have studied with the help of different videos, animated videos. Okay, so today we are going to study the stress strain curve. Okay, here we can see the stress strain diagram. On x-axis there is a strain, on y-axis there is a stress. Okay, here one dark blue color section, which is representing the material which follows the Hooke's law, that is stress within the strain, or stress is directly proportional to strain within the elastic limit, and the light blue color area which representing the elastic limit, up to which the elastic limit is there, and the yellow color area which represent the limit beyond the elastic limit or yield point. Okay, the stress strain graph has different point or a region as follows. The proportional limit, it is the region in the stress strain curve that obeys the Hooke's law. Hooke's law is what? You have studied that Hooke's law in the 11th or 12th standard. That is, Hooke's law is stress is directly proportional to strain within elastic limit. Okay, so in this limit, the ratio of stress with the strain gives us the proportionality constant known as Young's modulus, means up to which the stress is proportional to strain, or stress ratio of stress with the strain gives us the proportionality constant, and which is known as Young's modulus. And the line OA, which represent the elastic limit, which is known as the stress is directly proportional to strain within the elastic region. Okay, so this is nothing but the proportionality limit also. Then the elastic limit, stress strain graph. In elastic limit, it is the point in the graph up to which the material retain to its original position when the load acting on it is completely removed. Beyond this limit, the material does not return to its original position and a plastic deformation start to appear. Now elastic limit means what? Point number B. Okay, now in that case, uh, on any metallic bar we have applied some external force, uh, certain amount of external force. After means because of the external force there will be some deformation will occur in case of that metallic or steel bar. Okay, now after the removal of the that external force, suppose that steel bar will regain its original shape, then it is the elastic limit. Okay, or it may called as a its original position when load acting on it is completely removed. म्हणजेच तो जो आहे स्टील बार तो काय त्याच्या ओरिजिनल पोझिशनला रिटर्न होतो. ओके, अँड दॅट इज नथिंग बट द इलास्टिक लिमिट और इलास्टिक पॉईंट अप टू हिज द इलास्टिक पॉईंट. म्हणजे बी पॉईंट काय इलास्टिक पॉईंट आहे. त्यामध्ये काय होते की जर एक्सटर्नल फोर्स आपण रिमूव्ह केला स्टील बारवर जो एक्सटर्नल फोर्स अप्लाय केला होता तो फोर्स जर रिमूव्ह केला तर काय होते, तो जो स्टील बार आहे त्याच्या ओरिजिनल पोझिशनला येतो. म्हणजेच त्याच्यामध्ये जे डिफॉर्मेशन झालं आहे ते डिफॉर्मेशन काय होते, रिमूव्ह होऊन जाते. ओके, दॅट इज नथिंग बट द इलास्टिक लिमिट. पण as we are applying some external force on the same steel bar, in that case after the removal of that external force the steel bar will not be regained to its original shape. Means whatever the amount of deformation will be takes place because of the external force, that will not be removed by the removal of the external force. Okay, and that is the limit beyond the elastic limit. Okay, beyond this limit the material does not return to its original position and a plastic deformation start to appear. म्हणजेच काय होते, before point B there will be elastic limit, and after point B there will be plastic limit or plastic deformation. Now yield point काय म्हणतो, yield point चं म्हणणं आहे the yield point is defined as the point at which the material start to deform plastically. Okay, yield म्हणजे जो इलास्टिक पॉईंट आहे, इलास्टिक पॉईंट नंतर म्हणजेच पॉईंट सीला काय होतं की yield point, point C is the yield point. Yield point is defined as the point at which the material start deforming plastically. Okay, म्हणजेच once we have applied some external force on the steel bar, because of external force there will be deformation will occur, and that deformation is plastic deformation. Means what, as it will be appear that the plastic deformation occur in that steel bar, means it is beyond the point C, that is yield point. Okay, and yield point is of again two types, that is upper yield point and lower yield point. Okay, just beside that point C. Then ultimate stress point. Ultimate stress point म्हणजे काय, it is a point that represent the maximum stress that a material can endure before failure. म्हणजे yield point काय आहे की एक जो स्टील बार आहे त्यामध्ये प्लास्टिक डिफॉर्मेशन झालं आहे, आणि त्या सेम स्टील बारवर जर आपण एक्स्ट्रा फोर्स अप्लाय करत आहे, म्हणजेच मॅक्सिमम स्ट्रेस तो काय करतो, बिअर करतो बिफोर द फ्रॅक्चर होण्याआधी जो एक्सेस अमाऊंट ऑफ और मॅक्सिमम अमाऊंट ऑफ स्ट्रेस मटेरियल कॅन सस्टेन बिफोर द फेल व्हायच्या आधी. बियॉन्ड दिस पॉईंट द फेल्युअर ऑकर. बियॉन्ड दिस पॉईंट, त्या पॉईंट नंतर काय होते, फेल्युअर ऑकर. अल्टिमेट स्ट्रेस म्हणजेच ब्रेकिंग पॉईंट म्हणतो आपण, आणि बियॉन्ड दिस पॉईंट दॅट इज फ्रॅक्चर पॉईंट. ओके, आता अल्टिमेट स्ट्रेस पॉईंट म्हणजेच दॅट इज ब्रेकिंग स्ट्रेस पॉईंट डी, आणि पॉईंट ई काय, फ्रॅक्चर पॉईंट, त्यालाच म्हटलं आहे ब्रेकिंग पॉईंट. इट इज द पॉईंट इन द स्ट्रेस स्ट्रेन कर्व ॲट विच द फेल्युअर ऑफ द मटेरियल टेक्स प्लेस. ओके, तर यामध्ये काय होते, द स्ट्रेस स्ट्रेन कर्व ॲट विच द फेल्युअर ऑफ द मटेरियल टेक्स प्लेस. त्या पॉईंटला काय होते, फेल्युअर ऑफ द मटेरियल विल टेक्स प्लेस. जर तुम्ही पाहिलं असेल रबर बँड आहे तुमच्या हातात, यू आर स्ट्रेचिंग away from the center of that rubber band, and after removal of that external force or whatever the force we have applied to the fingers away from the center of that stretching band or rubber band, what will happen, that rubber band will regain its original position. Okay, once again you have applied external force on that rubber band, what will happen, it will be extend, means there will be deformation will occur. Okay, again we have removed that same amount of force, whatever you have applied on that rubber band, that rubber band will regain its original position. But you have applied some few, or what we can say, that some excess force that you have applied earlier, excess force than the force you have applied earlier. Then what will happen, there will be some deformation will occur, and that deformation will not be removed after the removal of the external force. Means again see here, there is one rubber band, you are applying the external force away from the center of that rubber band. What will happen, there will be some deformation will occur in the rubber band, and you are removing that external force. What will happen, the deformation also removed, or it will be come to the original point. Now you are applying some excess force than the force applied previously. Then in that case there will be some excess deformation will occur in the rubber band, and it will not be regained to its original point. तर जर ते जे काही डिफॉर्मेशन आहे ते चेंज किंवा रिमूव्ह होत असेल तर दॅट विल बी इलास्टिक deformation. And suppose there will be some deformation will remain in the rubber band, then it will be a plastic deformation. Okay, that is nothing but the fracture or ultimate stress. Okay, are you getting it, everyone? See here in the diagram, here we can observe the elastic region. Elastic region means what? Stress is directly proportional to strain, or we may call it as a Hooke's law, and stress is directly proportional to strain within the elastic limit. Okay, now the region from 0 to O to B, it will represent some elastic limit. Elastic limit means what? We are applying some excess force than the we are applied in case of the that is proportionality limit. We have applied some excess force than the proportionality limit. In that case, what will happen? Some amount of deformation will occur, and that deformation will be regain its original position after the removal of the external force, and that is nothing but the elastic limit, or what we can say that elastic point or yield point. Now the curve OC, which represent OC, which represent the as we are applying some excess force that we have applied in the as compared to the force we have applied in case of the elastic limit, and after the removal of that excess force, the that deformation will not regain its original position, and then it is known as a yield point, what we or plastic deformation. Okay, so plastic deformation means what? That after the removal of external force, the material will not regain its original shape. Some amount of deformation will remain in the what we can say that will remain in the material, and that is nothing but the plastic deformation or plastic region. Now at point D, we are applying some excess force, and there will be some deformation. Excess amount of deformation will be there, and it will not regain its original uh, shape. Okay, or we can say that this is the maximum stress before the failure of the material. Okay, so it can be represented in this diagram. See here, suppose there is a one second, this is the metallic bar which is fixed from one end, and we are applying some external force P. Okay, so that what will happen, there will be some deformation will be there because of the force P. Okay, and we are remove that force P, it will regain its original shape after the removal of the external force. Okay, so this is nothing but the elastic limit, and point B, which is represented by point B, elastic limit. Okay, and beyond point B, we are applying some excess force P. Because of that, there will be some deformation will occur. Deformation delta will occur in the material, and that deformation delta will not be transformed to its original position after the removal of the force P, and that is the plastic deformation, and which is plastic deformation. Okay, and that plastic deformation is represented on the graph by point P, or lower yield point or upper yield point. Okay, or we can say that the yield point. Okay, now point D, we are applying the excess force, and because of that the maximum stress will develop in the material. Maximum stress will develop in the material before the fracture. That is nothing but the ultimate stress. ओके, आता या केसमध्ये बघूया आपण अशा प्रकारचं नेक फॉर्मेशन होते. ओके, before after the fracture, and that is nothing but the point E. That point E representing the fracture of the material, fracture point. Okay, and which is represented by this way in the actual material. Okay, so this is nothing but the fracture of the material before the after the applying external force, excessive external force in the material beyond point D. Okay, so that is nothing but the breaking or fracture point, breaking point or fracture point. Understood? Okay, so that stress strain curve you have studied in the 11 or 12th standard in detail, and in physics also you have studied the stress strain curve. Okay, before studying the stress strain curve you will not understood the any material property, that is brittleness, ductility, Young's modulus, Poisson's ratio, that properties you have studied in the mechanics of material also, that is MOM in 3rd semester. Okay, Shionkar sir has taught you all the things. What is Poisson's ratio, what is elastic limit, what is modulus of rigidity, modulus of elasticity, okay, Young's modulus, bulk modulus, that all the parameters are related to the stress strain curve. Okay, so this is nothing but the information related to stress strain curve. Next we will have to study the three definitions, that is recovery, recrystallization and grain growth, that you have studied in the manufacturing process 1 also. Okay, when the temperature of metal is increased, means we are studying the casting process. In casting process we know that what we will do, we first manufacture the mold from the molding sand by using pattern. After removal of that pattern we will obtain the casting, we will obtain the mold cavity in the sand mold. Now we pour the molten metal into the sand mold. After the solidification of that casting, after the solidification of the metal, we will remove that casting by breaking the sand mold. Okay, now when we pour the molten metal into the mold cavity, means that recovery, recrystallization and grain growth we will study when we pour the molten metal into the mold cavity up to the solidification of the molten metal. In that phase we will study the recovery, crystallization and grain growth. Means we have a scrap, a solid scrap. That solid scrap will be, metallic solid scrap will be put into the furnace, and when we give some heat by using different methods, what will happen, that solid scrap will be transformed into molten phase. Okay, and we will have to study the recovery, recrystallization and grain growth. So from molten phase of metal to the solidification of that molten metal, we will have to study that recovery, recrystallization and grain growth. Now what is recovery? The partial restoration of the original characteristics produced by reducing the distortion of the crystal lattice without remarkable changes in microstructure. Means what? As we are pouring the molten metal into the mold cavity, there will be some partial restorations, means few amount of characteristics, few amount of characteristic will be remain as it is, produced by reducing the distortion of the crystal lattice without remarkable change in microstructure. म्हणजे जे काही मायक्रोस्ट्रक्चर बनेल आफ्टर सॉलिडिफिकेशन, okay, that microstructure will show some original characteristics of the crystal lattice shown by the parent metal, okay, and that is nothing but the recovery, okay, that is nothing but recovery. Then recrystallization, formation of new grains in the heating process of metal, means when we heat that metal, what will happen, uh, as the temperature of that metal will reach the temperature higher than the recrystallization temperature, and instead of that the orient fibrous structure of the deformed metal is produced, and that is nothing but the recrystallization, means formation of new grain in the heating process. Okay, as we are heating the molten scrap, solid scrap, and that solid scrap will achieving the higher temperature than the recrystallization temperature. That's why new grain will form in the heating process. New grain form in the heating. Okay, and the process of recrystallization illustrated through the figure. In this figure, you can observe the recrystallization region. Here, you can observe the recrystallization here. Okay. The first effect of heating of metal is to form new minute grains, and these rapidly enlarge until further growth is restricted by the grain meeting. Okay, so once the new grains will be generated in the recrystallization, the grain growth of the that new grains will take place very rapidly, and त्यांची grain growth कधीपर्यंत होते, when the neighboring grains will touches the boundaries of the grain. Okay, the new grains might rapidly enlarge until the further growth is restricted by the neighboring grains, okay, or wall boundaries of the neighboring grains. The original system of grains go out of the picture, and the new crystal structure is formed in the metal. Okay, so that is nothing but the grain growth. Now grain growth बद्दल काय, on recrystallization of metal the grains are smaller and somewhat regular in shape. Grains are same, just on recrystallization of metal the grains are smaller and somewhat regular in shape. स्मॉल ग्रेन्स असतात आणि रेग्युलर शेप, एकसारखे ग्रेन्स असतात. ओके, इन शेप. द ग्रेन इन मेटल विल ग्रो इफ द टेम्परेचर इज हाय इनफ. The grain in metal will grow if the temperature is high enough, or if the temperature is allowed to exceed the minimum required for recrystallization, and this growth of grain is result in of the tendency to return to more stable and larger state. Okay, the grain in metal will grow if the temperature is high enough. Okay, as the molten metal is having higher temperature, that's why the grain in metal will grow at a faster rate. Okay, and thus the growth of grain is the result of a tendency to return to more stable and larger scale. Okay, so that is the indication of the grain growth. Grain growth you can observe in the this region, means similar kind of crystal structure we can observe here. Okay, there is no randomness in the structure. Okay, that is somewhat similar. Okay, so this is the structure developed by the after recrystallization, that is grain growth, and which is the important factor or important requirement of the growth of the grain in the after the formation of new grain in the molten metal. during the solidification of the molten metal. Okay, so this is nothing but the recovery, recrystallization and grain growth. Okay, in the next lecture we will study the hot working and cold working process with their applications, advantage and limitations. Okay, so today we will stop here. Thank you.